need to adjust the microphone, or is that already in the right place? And it's not on yet, right? It's not yet on, so I have to afterwards turn it on when I start. I don't think it's on.
It's on.
It's not muted.
How do I mute? I'd like to mute until I start. Yeah. Oh, hi. Joe Kalin, the first speaker. Are you the...
I'm chairing this.
Chairman. Okay, good. Yeah. Topic.
We have 30 minutes, so if you could try and stick to 25.
Yeah, that's what I was planning on doing. Should be okay.
So I'll get up at
Okay.
5 minutes city standard.
Okay.
I mean, we're quite with time numbers.
Okay, good. Main thing is to get live here. I don't know. I came extra after the last presentation yesterday and just plugged in and everything just went, lit up and went. But, do we need to get some help? Is he coming? I came yesterday after the presentations, just plugged in my laptop and everything was perfect. With the gentleman, I think it was Andrew Weber was here. And it was, Chromebook, but I tried it yesterday after the presentation. It was perfect. I just plugged in. Maybe I have to unplug one time.
No, the first time is always a little bit.
Okay, I'll unplug for.
Okay.
Now.
Maybe you go outside of presentation mode sometimes.
Okay.
Plug in and. No, something happens. I can see.
It's.
But you have a second screen.
Yes, but it's fine.
You try going into the presentation mode.
Let's see if it just goes.
So good morning. Welcome to day 3 of GeoPython. I hope you had a nice dinner yesterday in town. Probably quite warm. I was with another group. I wasn't able to join you, but it was really hot just next to the river. So sure you got some of that heat as well. So we're back in a air-conditioned room, ready for the first session of today. First speaker will be Joseph Kalin. He will be talking about getting data out of CAD and into Python. Looking forward to your talk. So, is your mic working?
Okay, can you hear me okay? I thought so. Can you hear me okay now? Good, perfect. Well, good morning to everybody. I'm glad that so many made it here early for the first session. I'll be talking about getting, this is not quite correct, is it? Is this better now? Good, okay. I'll be talking about getting data out of CAD and into Python. My name is Joseph Kalin. I'm a civil engineer. I've been working predominantly in underground construction and hydropower for most of my career. I'm with Puri in Zurich, and my colleague, Martin Pike, is a software developer doing a lot of data science, and he's coming over from Bristol in the UK with the company Cognis. The work that we've been doing for the last 2 years or so is for what we call a decision support system for civil engineering, and we're focusing on hydropower, specifically hydropower waterways. So what is a decision support system as we understand it? It really is composed of 3 items. First of all, getting the data. We deal with scattered data. Is the microphone okay? I have a feeling that it's kind of coming and going. It's okay? Okay, I'm sorry. Yeah. Just wanted to make sure. I know it's really an annoyance in the audience when the microphone's not good. So really, like I said, three components. First, you have to get the data. Our data tends to be scattered all over the place. It's on different people's computers, laptops. It's different servers. It can be all over the world. It's in different formats. It's even in different coordinate systems, different scales. How do you get all this information together? So that's the first goal of our decision support system. Once you get all the information together, then you can do stuff with it. You can do engineering procedures. You can write algorithms to process, to calculate, make engineering calculations, to do data analysis, that kind of thing. And then finally, you can present the data in a kind of a dashboard with different views, 3D views or mapping views, whatever it takes, with different performance indicators to show you whether your design is meeting the design requirements. So here's an example of how it works. You can see a hydropower site with the reservoir at the upper right and the powerhouse at the lower left. and with a tunnel alignment in between the two. This is shown as a vector graphic, the red alignment. We refer to this as the tunnel alignment. And you can see this overlaid on a raster topographic map. This is on a website. And we use this, for example, to make a what-if analysis. You can see that this tunnel is taking kind of a dog leg, the long way around, because it's crossing a tributary stream. And this is fairly deep, and we have to cross underneath it. But you wonder, maybe I can make the tunnel a little bit shorter by moving the tunnel alignment down slope, and what if? Does the design still work? Okay, so now you can see a result on a profile. You can see that on the right that you've moved the tunnel closer to the surface because you've come down the slope. And just kind of as to show that things are working, you can see a graph below graphing the overburden. But more importantly, at the bottom, you see a performance indicator for something we refer to as hydraulic confinement. This is not super sophisticated, but a real engineering analysis whether the tunnel is going to leak or not under the internal pressure from the reservoir. Okay, so what the website does is it sends this data to a Python server, Flask server. It then runs the engineering calculations, sends the answer back, and the answer is in the green, red, and yellow indicator at the bottom. So you can see the design on the left works. The design on the right, where we went under the tributary stream, is red and yellow. That would mean we'd have to line the tunnel with steel, very expensive. So basically, it doesn't fulfill the design requirements. This is basically what we want to do. So you say, well, we have a website. It seems to work. It looks pretty good. It needs a little bit of tuning. All we need to do is to put in a lot more engineering calculations. We're pretty ambitious in what we want to do. We want to do scheduling. We want to do costing. Basically, all the routine design tasks that we normally do. Take the boring part out of our daily jobs, put it into the computer, and we do the interesting stuff. That's the aim. Except it didn't work. Not yet. The reason is the data. Getting the data out of CAD. So let me ask here, how many of you work with CAD or supervise, draftsmen, staff, technicians working with CAD? 1, 2, 3, 4, 5, 6. Okay, a handful. I was kind of expecting that. So I hope the rest of you find it interesting. We touch on a few other topics as we go. But well, maybe one other question. How many of you have to work with CAD data? Data from engineers, if you want, from civil engineers. Oh, this is a whole bunch. Okay, well, that'll be good because we're basically, our topic is really related to getting CAD data into GIS, into Python. Good. So how to get topographic data, geometric data, geological data out of CAD software into Python. And what we found out, and this was kind of a real aha moment for me as I started using this system more and more for more projects. I would go to the team, the project team, or the draftsman and say, hey, give me the data. I need topography, I need the alignment, usual stuff. And what I found out was that what I got back wasn't what I needed. There was just a real mismatch between the data. And how do you handle this? And one of the problems is that the draftsmen, they're not really trained to deal with data, to export data. They don't understand the different formats. They don't understand the problems with making data from CAD work in, say, GIS. So here's an example of what we're dealing with today. I mean, normally, at least for most of my career where we've been digital, where we're using CAD, say the last 20 years, it's 2D. And the purpose of CAD mostly is to make engineering drawings, construction drawings, design and construction drawings. But more and more now we're using CAD in order to do 3D for visualization because it's expected. The problem is most of the draftsmen, they're using it to kind of paint the 3D. It's not a geometrical model. It's not, for example, that you take a tunnel alignment in 3D and you sweep a cross-section of the tunnel along the alignment and you have a real 3D model. what you end up with is some kind of wire mesh. It's rendered, it looks good, but it's not a model. And in addition, the components aren't structured. What we're showing here is, if you see the red, we have a powerhouse with the transformer hall next to it. And the blue shafts going up, these are pressure shafts for taking the water from the reservoir. Okay? And at the bottom, the red is taking the water back into the river, the tail race. And it's mostly here, the light blue, we're going to be focusing on, because these are, in this case, drainage galleries, because this powerhouse is right under a reservoir with a very, very large dam. And water can leak into the powerhouse, and that would be very detrimental for the operation of the powerhouse. So you need to drain, use the drainage galleries, a network of drainage galleries, to keep the powerhouse dry. Okay, so the first way of going after this was, and I knew this from a long, long time ago, DXF export. That's, I think, what most people are still doing today. The problem is first of all, you have a lot of work in CAD in order to prepare the data, a lot of data cleaning. You need to locate exactly the alignment that you want to export, in this case, one of the drainage galleries. You need to isolate that. CAD works in layers, not in components. You have to isolate that. You have to pick all the segments along the alignment that you want to export. Usually there's this explode and purge cycle you have to go through, and then you have to do a lot of checking. You find out the origin is in the wrong place. You find out the elevations aren't properly attributed. There's a lot of pitfalls. You get all that right, okay? You can then take a look at your DXF by hand. That's what DXF looks like. It's not always looking the same, because in this case, the alignment is something called an ACDB line. You can look it up on the Autodesk documentation. You find out what it is. You find out what the code is below it. But basically, as you can see, you have a start point and an end point. That's just one line segment. So then you can go to, for example, grass. We've been using grass for this work to get the DXF data into the Python environment. Things like VN DXF do work very well. Then we do a lot more reporting to make sure that you don't have any extraneous data, that we have the data we want. And then finally, we have all these often we have a lot of line segments. They have a starting point and an ending point, but they're just a whole set of lines. You have to build a topology, but GRASS offers good tools to do that. When everything goes well, you can use these then for doing interesting mapping and plotting. Here's an example of that same alignment you saw before. The light blue, it was the upper one, on a GRASS elevation relief map. Here you see that same data on a 3D Plotly data plot. This is showing up on the upper left is where that alignment is that I was talking about before, the drainage gallery. And you can see a lot of data which relates to the hydraulic characteristics of the underground. The light blue, the two shades of blue actually refer to hydraulic conductivity. We call it Lujon testing. The green is grout take, the amount of cement that could be injected into the rock adjacent to the powerhouse. And the purple is seepage that was recorded into the drainage gallery itself. So this gives you a really good way to visualize the data, to look for problem areas, and this is really what we want to achieve. So it worked. I mean, we can export CAD with using DXF into GrassGIS and into the Python environment, as you've seen. But it's a tedious bit of work. I would call it cantankerous. It can work one time, and Draftsman changes his data a little bit, his CAD data, and it doesn't work. You have to make some more changes. You can't really program to it. You can script it, but you have to build in a lot of checks. Okay? And then I saw there's another problem. You get a lot of data. And we've been working on doing the prototypes, building up our basic engineering analysis in Jupyter Notebooks. But as these get bigger and bigger, we try to move these into functions and move these functions into modules, and then you're organizing things into classes and methods. And the engineering calculation part works great, but this class structure doesn't really tie in very well with all the data we've generated. All the CAD data, the GRASS data, CSVs from pandas, this kind of thing. So how do you make these two match? That's another problem. Well, today we're really entering a new era in CAD and in civil engineering digitalization, BIM, Building Object Modeling. I think this is really coming strongly on board everywhere in the world. I know in Switzerland, it's really just been in the last year or so where our offices are using a lot of BIM. The interesting thing is, I mean, it's the same draftsman. Maybe we bring in a few younger guys that have been trained at institutes like this one. It's the same software, but it's a very different way of working. The emphasis is on modeling. You do, as I mentioned before, you define alignments, you sweep cross sections. Along those alignments, you build up 3D objects. And it's, in that case, in that sense, it's a lot better platform for getting data out of. We're going to be concentrating here on simple geometry, points and alignments, but we want to extend this to edges and surfaces and volumes, like you see in this model here. So, BIM. What is BIM? I call it the promise of BIM. BIM's been going on for 20 years, but it's really just in the last couple of years where this has become so prevalent in civil engineering offices. BIM is about data. It's not just about painting a visualization. It's not about producing engineering drawings, construction drawings. It's about the data. The data is structured, so it can be used in many different ways. And in addition, you want to structure your model with components. So if you go to a draftsman and say, I want a model for the drainage gallery, he knows what you mean, and he just gives you data for that one part of the project, that component. You don't get 1 or 2 gigabytes of a huge model like the one I showed you before, which was the case before. And most importantly, because you have these data structures and because you have you're organizing after components, you can share this data readily across the project. That's the aim of BIM, is to be able to share data across all your project teams and across all of your different platforms, all the different CAD and BIM vendors. Now, what we're going to be talking about for the rest of my presentation are industry foundation classes, IFC. I'll call it the lingua franca of BIM. And interestingly, it's both a data scheme and a data exchange format. Now, it's important to know that BIM is in progress. It's not yet, the promise is not yet fulfilled, but a lot of software is going in this direction. So probably technically we can say that BIM is here, but projects are not using it in a way that would be required in order to really efficiently use the data. So, IFC. What does IFC look like? Just a real quick example of a cube. You can see the IFC on the left. You can see that there are a lot of points that are Cartesian points, which are shown in the IFC statements. And above that, you can see that these are collected into a loop, and the loop is then made into a face. This is just for the upper face, what I'm showing you here. But this just gives you an idea of what IFC looks like. Now, we have IFC now coming from BIM, given to us, say, by the draftsman. What do we do with this? We still don't have data that we can use for GIS and Python. Well, one way to do this is simply to parse that IFC. And there's a good Python module called IFC Open Shell that one can use to parse IFC. And this is just an example here. It has many, many useful methods, but one method is by type. and you can tell it, give me the Cartesian points, and you get all the Cartesian points. This is just an extract here of a couple of points. You can use another method called getInfo, and you get coordinates. It works, it's fine, but it takes a lot of trial and error. You really have to look at the IFC data to see what you have. As you can see, you have to know the indexes of the points you want to get. It's not really a straightforward solution where you just take the data and use it. You have to do a bit of manual work, but it works quite well. And by the way, if anybody's interested, IFC OpenShell, it's mostly used for actually drawing stuff. You can get data out of CAD and BIM, but it can also draw stuff back into CAD and BIM. It's a very useful utility. Then, another approach, linked data. I've been talking to different people here. I think a lot of people do know about linked data. How many people here are familiar with linked data? You just raise your hand. Not so many. Okay, we'll be giving you a brief introduction to linked data. Okay. This goes back to the semantic web, if any of you know this history. We'll be giving you some examples. But it has many different aims. There's sort of administrative aims, or ways of working aims, as well as technical platform aims. But we start off with the easy stuff more, if you want the organizational issues. Naming conventions. You try to name things the same. Use a common vocabulary. One example would be, some of you probably heard the geology lecture yesterday afternoon. A very nice presentation, I thought. And you saw some nice geological visualization. But how do you get that data from the field? It turns out that all geologists log their data with different names. So their header field looks different. And for the engineers, this is a real headache, because every time you want to parse that data, you have to go back and change your way of doing this. Another thing is that linked data uses URI as the namespaces. So if your URIs or URLs, you're actually pointing to something. You can see the data on a website, essentially, in a browser. And by the way, on the first day, there was a presentation, Wikidata. How many of you were there? Yes, that's linked data. That was your introduction to linked data. Now, we're going to be showing you Triple's database, a Triple's database example. That's really the technical heart of linked data, and then showing you some example queries using Sparkle, and specifically using GeoSparkle. And what's the aim of all this? The aim of all this is what I showed you at the beginning, to make these geospatial mashups with data, whether it's mapping or whether it's a 3D data plot, like I showed you before. So, Triple's database. By the way, for those interested in such things, we're using Apache Jena. But the Triple's database stores triples. Triples is a subject, a predicate, and a value. So if you look down below, there's an example just for what we call a head race tunnel. This is a pressure tunnel between a reservoir and a powerhouse. And in this case, we're saying that this head race tunnel, it's instance data, so a particular head race tunnel, it's part of the works of the project. We're just calling it Nam Hydro Waterways. That's the name of the project. So that's basically a simple triple. That's how it works. And if you take a lot of triples together, you get a graph. That's why you also hear people talking about graph data stores. Triples database, graph data stores. In a practical sense, you can consider them to be the same. And by the way, we found, for those of you that are working in this direction, we found the turtle syntax to be very handy. That's what we're going to be showing our examples in. But it could also be JSON. Specifically, JSON LD is used for linked data. Okay, just to see where we're going here. Our way of working is basically from BIM. We've shown you this. And then we go to IFC. And RDF is the framework, the resource description framework, which is what linked data essentially is. And this is then in the Triples database. From that, we do querying using GeoSparkle, take data into the query data back into Python, and then process this further with GeoPandas and WKT. Okay, we use a transformation called IFC to RDF. You can see an example on the right. I don't want to go into this in detail here, but you can see it's very verbose. But on the other hand, it's very precise. For example, if you look about midway, you can see that the coordinate of 500, in that example, it's a double. That's nice to know. It's nice to know what your precision is. The Sparkle querying, here's an example using Sparkle querying. It's the same as was shown with the wiki data. You have a where. You can use where to then chain a series of queries called a property path. And from that same data I just showed you in the previous slide, you get the coordinates shown at the bottom right. Now, we did say a couple of times that the IFC to RDF output is very verbose, and this makes it more difficult to do easy queries and to put data back up into your triples. So we've developed our own alignment ontology. We call it a lightweight ontology, a domain ontology, in order to do this. And you can see at the bottom an example of this. I think the main thing to look at is this is for one point. You can see that when you enter data, you're entering, for example, your coordinate system, the CSR 84 is defined. You're telling it it's a literal. There's a lot of information you're putting into this data. And then another example of getting data out from our lightweight ontology using GeoSparkle. You can see here, because we've done this in WKT, you can see you get WKT points out. We can then take these points using Shapely and WKT and do all the usual stuff. This is just examples. We can do a coordinate transformation here from WGS84 into Swiss coordinates. We can get distances between coordinates. You know all this stuff. I just want to show you that we can come all the way from BIM and get the data here, points data, lines data, into Python and do stuff with it. That's what's interesting. What we found was that WKT does work very nicely with 3D points. You have these Z types, like point Z or line Z. So where does this lead us? Basically, it works. You can get IFC points to triples, into GeoPandas, into WKT, and then do engineering with it. It works. I say it works well for now. The reason for now is you can question how stable some of these standards are. For example, GeoSparkle is a really nice tool, but it's kind of stagnated in development. At least that's what we see. WKT, I think there's a lot of divided opinions about how good these simple features are. We found it works well, but is that the future? We don't know. So we want to stay pretty nimble, not really fix ourselves too much to one technology, but we have found a data pipeline that works for us quite well. And interestingly, I hear from a lot of BIM people, geometry is hard. You know, GIS says, I mean, you do geometry, basically geometry is easy. In BIM, conversely, geometry is hard. And we hope now with this methodology to make geometry in BIM easy. One further example, we can now take data that we enter in Python and in WKT, for example, and use GeoSparkle in order to update the triples database. We can put data back in, so it's a round trip. And this is the way that we effectively map the BIM ontology data you saw before. This was the IFC to RDF, the rather long data I showed you, how we map that data to the, what I called the lightweight alignment ontology. And by the way, I didn't define what ontology was. Essentially, we can think of this as a data scheme, a way to organize your data. It's Or it's basically one of the main components of linked data, and it's how you work with triples. So you see on the bottom of the example where we've taken the data um, from pandas and then put it back into the triples using insert data as above. Okay. Here it's just hand coded. I mean, this was just an example. In reality, you would have a query string that comes from Python, and you can put all your variables into that and do loops or whatever you need to do to get a lot of data back into the triples. Just as a sneak preview of a lightning talk that my colleague Martin is going to do in the afternoon, we're going to be using essentially the same kind of technology to draw stuff, to put engineering know-how, knowledge into design rules, and using those design rules to produce engineering drawings in BIM. Okay, thank you very much. I'll be very happy to take any questions you have.
Okay, just hang on for a second for the mic. Okay.
Thank you. A question, GeoSparkle, so generating a string from Python to produce another query language. Do you have some kind of ORM, so like object relational mapper?
Sorry, I didn't get that last part, using GeoSparkle.
So because you generate a string which represents essentially another programming language. In Python you have like SQL Alchemy, which is an object relational mapper. Does anything exist for this field? Would it make sense? Would it make things easier?
We're not using it. I'm going to hand it over to the data expert, Martin, to see whether he knows what other people are doing in this. Martin?
To my knowledge, there's nothing that does that. You're writing. I'm not sure it is, because you don't have the same complexity, because effectively you're dealing with one table with the triples in.
Okay, you don't.
Sorry.
You don't have joins and stuff like this and all this kind of jazz that you typically have.
Not on the outside. That's all implicit in the handling of the data itself.
So you don't see a lot of improvement adding another layer on top of it and abstracting things away.
Somebody will do it sometime, I'm sure.
Okay, thanks.
Another question here.
Okay, hello. Yeah. So this is, I'm the geologist from yesterday. So
Oh, nice to see you here.
So my question obviously is, I didn't really get a feel for the geological data that you're using, or like how do you handle some of those? Like, is it geological volumes or?
I did not present that here.
Yeah.
That's correct.
Okay.
If you looked at that 3D plot that I showed you with the data and the alignments, the full version has all of the lithological contacts.
Okay.
And all the faults, and then you can get a better impression of the data. For example, do you have higher hydraulic conductivity along faults would be an obvious question.
Okay.
And how we get the data, yeah, we struggle. This was about getting data from CAD. I could give you the exact same presentation pretty much, getting data from spreadsheets into Python. But it's somewhat easier to handle, you have more control. But yeah, basically you have to take somebody's spreadsheet, map it into another worksheet and try to put it into a way that you can put out to CSV and read into Python.
Okay.
And like I said, yes, data can be messy and people make mistakes in entering data, all the usual stuff. But the big problem is people name stuff differently. And it's not just about what a rock is called. I mean, we can discuss that, but even just what the headers are.
Yeah, no, that sounds like a very realistic issue that I face as well. I did want to make a comment about the naming convention. There might be some things available now, and I'll check it up just to be sure I can tell you about it. But there are some automated conventions for like logs and wells now. So if something is like, say, like a gamma log, and it doesn't matter how it's named, once it's under the category, it can get filed separately. So I don't know if that's something that you would be interested in, but
thanks. We've looked at some of those, and by the way, there are standards.
Yeah.
For example, the UK, I think it's the British Geological Society, is very good in this. I know a lot of times at construction sites, we end up using a lot of what they have just because there'll be one geologist who was trained in Great Britain and he has all this information. And that's good, but not everybody works this way and not everybody sticks to the standard. Then this guy goes away and the person replacing him does it a different way.
Okay, before taking any further questions, I would like to make sure the second speaker is in the room. Chen-Fu Wang. Is it you? Okay, just wanted to make sure that we don't cut the discussion and then, okay. So you might want to get ready in the meantime, and we have time to take one more question. If not, I have a question. On Monday, I learned about PyRevit, Python
Yes.
API for Revit. Since you're using Autodesk product, have you looked into that? This might be a direct way of getting from BIM to Python.
Yeah, it's interesting. I was at a conference last week called LDAC, Linked Data in Architecture and Construction. And it's the intersection of linked data and BIM. And these were about 60 very enthusiastic, motivated people who are trying to make this connection. And there was one group, it's a German research program called SCOPE. They've decided that IFC doesn't work for them. Just to make everything clear here, not everybody believes in IFC, even though most of the world does, and they want to basically provide a binding to every API out there, including Revit, and then to have some abstraction layer where you use to actually move things in and out of. So it can be done. I wish them luck. I think it's a very hard endeavor. And not everybody's so happy about Revit APIs, so it's a hard API to program to for most of us more engineering types.
Okay. There will be alternatives such as BIM server, open source alternatives, but yep.
Yeah, there are different alternatives, and people are trying to figure out how to make this work. That's correct. This is not the final way, but it's a way that does work at the moment. I think it's going to achieve our purposes fairly well.
Okay. I see the next speaker is ready, so we just switch microphones. Thank you again for this interesting presentation. So the next talk will be on geomapping with pie charts, given by Chen-Fu Wang. And I see your mic should be ready as well.
Hello, can you hear me?
So the floor is yours.
So the first question before I proceed is that as a general question, so how long does it take you to draw a map? I have had this question long before, and I've been working on that question to get the answer myself. So, and then because I'm had this question, and also because I'm an engineer, and I'm a software engineer, I'm doing web programming, so I have some of the answers, but then not all the answers to you. And so to bring in here is I got the flying plane example. So it's written because I'm coming to present a talk, and then on the plane I saw a graph. It's showing our plane is coming from London to Basel. So I thought probably I can use that as an example to illustrate what I mean. And to use the notebook, you can have it, and that's in my the GitHub repository, the GeoPython talk. You can take a note. And to get it working, you need to install PyCharts. And so let's go. So, and remember, this is what I'm going to implement. So with the PyCharts and the geomapping, I need to zoom in the global map, centering on the Western Europe, where we can see Switzerland and London. And what I also need to do is that to mark out the London and Brazil. And then I choose a plane, then I fly it. So that's how I come from. That's my story, how I come to the Basel So coming back to the presentation, I'm coming here to present the work I've done about 2 years ago. Having had a question, having found a PyE chart, this library, then I found it that probably of some interest to GeoPython community. About me, I'm a Python consultant. I work in London. I know a bit of JavaScript. And this talk presents my open source activity. And at my work, most of the things is web development, and both front end and back end with JavaScript. And I have some libraries on my GitHub. You can find the if it's useful to you. So in PyChart, especially in the geomapping area, the challenge we are having is that to help people to draw maps by themselves. And the use case is more regarding the people who know Python, but do not know much about geomapping. And I was at that stage as well. I know Python, but I do not know where I can get maps. How do I draw the map and then visualize the data on top of the map I found? That's the challenge. And this challenge is found when we progress in the open source community. People started to use our maps, and they started to ask questions. A lot of assumption, we are assuming, oh, you must be a programmer. No, actually not. Their profession not coming from programming background, but they want to use it because they find the needs in their work. They want to visualize data to help their business, to help to communicate with other departments, just to visualize the data. The simple need. And what is PyEchart? It's an interface to echarts.js. And actually, this is a story here that it was done by a Chinese undergraduate at year 2. And people always getting surprised when they come to the PyEchart to ask questions. Oh, you're so young. But me as a contributor to PyEchart, so I'm working with him for about 2 years now. My interest is in maps, as you understand. That's why I'm here. And eChart is released in 2013. It's not young, this library. And at the moment, it had 34K stars in GitHub. And now it's Apache licensed. And it's very popular in China, including in industry and academics. They use it. There's a small table in there because the screen is so big. And who has used high charts? 2, 3, right? And charts.js? No. C3.js is coming from D3, and then it's made much easier to use. And this lower one is eCharts. So on the 3 categories is that can you extend the charts easily? Can you add custom interactions? Do you use Canvas? Canvas, it will be able to, you're not using HTML elements, but using a canvas where you can freely draw the graphs. And on the 3 categories, each strikes all the boxes. And then for pie charts, now then in this category, there's matplotlib, people use it, okay? And plotly, okay? Vulkan, okay? And so pie charts in this aspect is not well known in this community, and because it's 2 years old. And then we looking at the GitHub trending is just shooting up like a rocket in the GitHub trending. And so then the reason why PyCharts I'm trying to promote that is that it's really simple to present GeoJSON. I can forget about the projections. I can forget about rotation to get your geo shape in the center. And by default is interactive. You can click around, and for other libraries, you need to add by yourself. Digital native means that if you have the graph generated, you can share already into with the web. So at the moment, we got some geoshapes here. Before that, I give you another one. So for world populations, there's easy charts from here. So with the e-charts, pie charts, you can do loading the table, etch them in, and then sort them. Select the columns you are interested. Get country and the population. Get the highest number, and then you render it. We now get the world map, but however, the value was not presented. So I would need to add an additional component which says high, low, and max, min, and give the color. So now you get the color, and then China is still the highest country in here. With these interactions, I didn't do anything, but then I could now filter out by the countries. And you would notice that this few countries hasn't got color branding, and then that's because the naming on the map and then the data we got from outside is different. So this name map will be able to link the data together. So if I run that again, now these areas now is colored and with the corresponding values. And with one of the feature to be released for the next version is map globe. What it means is that this is 2D graph, and I can do, this is a zoom in. By changing the code, mentioning this is a globe, hopefully it works. And now we're turning into a 3D model of globe. The same value also present here, and you're getting the graph in a globe. Okay. So with the tool set and in place, the challenge still present is that where do I get geo shapes? Once you get the geo shapes, then it's easier to get into the library and then present in the Jupyter notebooks. And so that's the way I have been doing it. I collect all the geo shapes and put in the GitHub, and people can use it right away instead of doing download some of the files or mix and match by himself and then present in Jupyter Notebook. Our approach is that just having the GeoShape there, you pick and choose, and quick to get it presented. And in this presentation, I will cover the techniques used in create all the geomap assets, and also share the tips that we have been using to integrate a external JavaScript library with Python and integrate with Jupyter Notebooks. I know you will be interested in your JavaScript libraries. You want to bring into Jupyter Notebooks. You can take some of my tips. And then the last one depends on the timing. If I got extra time, I will be going through the third part. If I missed it, there's a link. I had a tutorial on the GitHub. You can follow that, and then we can discuss it a bit later. And then for the part 3, just one note. It needs Node.js. Is a bit of knowledge is required. So first of all, where are the readily available geo shapes? And I find that when getting the geo shapes from the government is always accurate, and there are a few countries has already taken this open data initiative, and really helps to get geo shapes. And the second place is natural Earth data. It have a well coverage around the world. So if you're struggling to get a shape that you're after, natural Earth will be good source to look at. And the third one is OpenStreetMap. OpenStreetMap can export geoshapes, road, and structures together. You can get exported and convert into GeoJSON. And the first one is Scouter Maps. It's coming from China. And most of the geoassets for Chinese regions was scraped from this website. For those maps, then there's a license that if you use commercially, then you need to get Scouter Maps involved. And then if it's free usage, and like Google Maps, as long as the public has a fair access, they wouldn't be subjected to commercial license. And the fifth one is draw it yourself. And fifth one, if I have time, I will cover in the part 3. So how to draw the shapes by yourself. For the geoshapes, we have a collection, have a list, but then maintenance is also a problem because geoshapes itself evolve. They get name changed, and because of the political structure changes, some new district join a city, they can just get expanded, and we need to reflect that. And also, different districts get merged together, so, and then triggers another need. And for the user's needs, we have the shapes, but then always the user's needs changes. So, for example, the first one is that someone wanted to have geoshapes with internal borders. For example, Basel, if you have Basel here, people would ask, do I have a sub-district, political district within Basel? Then we need to then put the borders inside. Some other people then want, just give me Basel. I don't want the internal borders. So these things we need to take care of. Then there's a custom groupings. For example, people asking, how do I draw Europe from world map? I just want Europe. I don't want to draw other things. And the third one is custom projections. So to illustrate, people wanted two sides. Either one will suit their needs, and we need to provide. And custom regions is the same map, but then because they categorized differently, group them differently, then they can visualize the data. Potentially, they can say, my cells in northern China is of this much, and then southern China is a certain figure. Then with the 7 regions grouping, you can clearly show that. And this is much smaller. This is projection is that I find it very interesting. People looking at the standard map on the left-hand side, where UK is in the middle. However, when you come into Asia Pacific, people wanted to put their country in the middle of the map. And then comes to 1-year-long question. I finally fixed it. I first met Martin on the GeoPython, and then Martin said, yes, you can do it. There's a way to get the GeoJSON reprojected and showing. So finally I get that. And coming to part 3, so to integrate JavaScript library with Python. So what a Python interface is taking your data directly, and you say which of the coordinates and the map type you wanted to have. That's the interface, and we generate you a HTML file. This file, once you get that, and then you're happy with it, it's ready to be shared. You can have your own static server, or you have any cloud-based static file server. Just place the file on there. You're done. For Jupyter Notebooks, Jupyter Notebook itself have they use require.js. So what we do is that we configure require.js on the fly. We say our map objects, our charts will require the echarts.js, the min and world map put inside. and then we have a HTML element as a placeholder, and then inject the script in the third category where we require e-charts, world, and then do the function. Inside the function, then we started to draw the map. So in the part 3, we'll be trying to do the map drawing. And you need a eCharts map maker. This is another library of mine on the GitHub. So what I found is that there's a website called geojson.io. Just log in, go to the website. You had a world map. To draw Forbidden City, I need to navigate the map into the Beijing and zoom out, see the Forbidden City, and then started to use the polygon tool, and then just dotted the dots around it. And if you go into the website, you will see on the map, on this interface, on the right-hand side, you will get a GeoJSON out. Once you finish, you're happy, you can get it out. There's only one thing is in JavaScript, is a step 2. We need to convert GeoJSON to a JavaScript file and put the registration name as the Forbidden City. Why? The first thing is that GeoJSON could be big, really big. Once I downloaded United Kingdom JSON, the shape files, and converted to GeoJSON, it's 198 megabytes. If I host it on my static server and then transfer to my users, user will die. It's too long. They will not take any website. So by using this JavaScript, it does UTF encoding. So map all the geocoordinates, compress all the geocoordinates into a UTF. UTF representation. It does zigzag delta scanning, and then transfer the characters into UTF representation. Then that will shrink the 198 to 9 megabytes, which is sort of okay-ish. Step 3, for your own JavaScript, you need an interface file. It's a registration JSON file. What you need to say is that the Forbidden City name on the left-hand side, on your left-hand side, is the file on locally, meaning is the Forbidden City.js. Then you host it in your current directory, host the map. If you use Python 2, then it's a simple HTTP server, but then PyEcharts require minimum Python 3.6. So you may have used that. Once you host it locally, then you are ready to integrate with PyEcharts. What do you do? For the integration, you take on the dataset, register your local server. That's all. Then you are ready to go. The important bit is the map type. Map type here is the one, as you said, the third parameter, the space forbidden space city. That's the name to use. Once you render it, you get the HTML file in your current directory. That's the one you will get as HTML. You can take it to share. And in the Jupyter notebook is the same code. It's the same code, but then you notice that this URL is different. And the reason is that this local server is only for yourself. Once you've done a good shape, good data you want to share with people, the reason to put the URL there, this is one way of sharing. You put the maps you have done. You go to GitHub and host it and create a settings page, make a GitHub page yourself. The file will be ready for you to take it. And alternatively, you just get a registration JSON and a JS file committed together, put in a static file server, which is publicly accessible. Then you put a link here. You register that. then you run your script, then we get a shape here. So the things has been done about in the last 2 years or so. One of the things what you can use the maps to do is here. You can also take this link and have a look. It's a short link bit.ly 2rxl to x3. So give you a moment to note it. This is how you will use pie charts in action. So I'm going there now. And you can use it to draw this is 2017 general election in Britain. So it's Theresa May getting to power, and then she thought she wanted to be re-elected with a mandate. Then she triggered the election. That's the conservative. The blue one is the conservative, and the green one is the only one which is independent. And so the London area is the red color is Labour. You could see that London area is pro-Labour, and in this we can zoom it out. So this is the Great London area. This River Thames. And what tripled the government a bit is there's a DUP here, Democratic Union Party. They rise to power in Northern Ireland, and Theresa need to take a bit of power to get them together to form a government. So that's all my presentation.
So, questions for Chen Fu?
Hi, thanks for the talk. It was really interesting. My question was really regarding raster data. So do you have the ability to render raster data in that environment?
In this one, we are not rendering raster data. Mainly, we are using a GeoJSON and render into a SVG, and you could get an SVG out. We can also overlap, put GeoJSON overlap onto a map. At the moment, the support is around in another Chinese map provider called Baidu. There's a Baidu map. We can overlap all the geoshapes on top of the Baidu map. And then you can do the zoom out, zoom in. You can do that.
You mentioned the OpenStreetMap support. I was not sure, are you able to directly import the data? Do you provide an OSM importer, or do you even have an online access to an OSM background?
Do you mean the files or the geoshapes?
You mentioned the possibility to use OpenStreetMap data in pie charts.
Yes. So that one is not online. It's a bit of offline processing is required. The use case is people wanted to have the streets, the road maps showing, and for a certain city. And the way to get them is from OpenStreetMap, and then need to export and convert offline. Once we get the line, a GeoJSON in line, then you can come back to the geomapping and then process them.
Okay, thanks very much. Further questions for Chen Fu? One up here.
I didn't quite understand the step where you had the GeoJSON and then you ran make.js with the GeoJSON. So the make.js, is that part of pie charts, or is that the third-party tool?
Yes, make.js is the only one which is not Python yet. is This tool is eChart map maker. This eChart map maker does the compression to GeoJSON, getting compressed and get a JavaScript out of it. And it can also do the reverse to decode UTF encoded GeoJSON back to the standard GeoJSON. So that's the one step to squeeze them to as small as possible to share on the internet. This tool you will need Node.js installed, and then use a package called npm install eCharts map maker. Then you get make.js.
Thank you.
Okay, are there further questions for Chen-Fu?
So this is the full tutorial on the website. It tells you how to, one step by step, how to do that. And what your question is the second question, how to integrate it. So you need to install it. That's the formal question.
Okay. If there are no further questions, I would like to conclude this first session. Thanks again, Chen-Fu, for your inspiring presentation. And it's now time for coffee break, and the following session will start at 10:45.
master's face. Machst mich grad nervös.
Okay, hi everybody. We're going to have two talks by Professor Hans-Jörg Stark. The first one's going to be about getting information out of an Apple Watch, and then a talk with a Raspberry Pi and working with a camera. Okay.
Thank you. Is it working? Okay. Well, yeah. So my first talk is about well, I call it the sporty side of Python. And what I'm basically going to show you is I have one of those fancy things like an Apple Watch. There's many of those around nowadays. And what I came up with was that I found it cool. I don't know how you work, but for me, everything that I can measure has some kind of attraction to me. I don't know why, be it temperature, be it whatever. You name it. And among other things, I noticed, of course, that my Apple Watch is able to give me a feedback on my pulse. And since I'm every now and again doing some sports, I'm interested what's about my heart's performance, etc., etc. And I found out that, for instance, it's interesting to see when I'm laying down, what's my pulse? So do I have a high rate, do I have a low rate, etc., etc.? And so all of a sudden I had this idea, why not kind of like track it and see how it's performing over time? So speaking of which, you can see basically just the interface of my watch, what it comes up with. So you can see on the picture the frequency, beats per minute, and also there's a little diagram, etc., etc., and you can see the time, etc. So what I thought was, why not regularly make a picture? That's very easy. You can just press those two buttons, and it makes basically a screenshot, and then transfer it to my computer, and just play a little bit around with it. So basically, what I did is I also found out that there's two kinds of information. There is a pulse that's the pulse now, the current pulse, and there is a pulse information like when I'm really sleeping, when I'm asleep, so kind of like an average value. And normally, of course, the so-called the quiet pulse or the Ruhepuls in German is supposed to be lower than the actual one. So, for instance, this morning when I got up and just remembered I had two presentations, my pulse went up, of course. Yeah. So that was too far, wasn't it? I don't know why it's not doing anything. Is that or not? Okay. So what I did is I tried to kind of like with some kind of image recognition, try to extract the information of the number, of course, those 45 that you can see on this picture. And I had a first simple try, which means basically I
I was applying Tesseract. I played around with some things. I'm absolutely not into kind of like image recognition. That's not my background, not at all. So don't expect me to be anything but proficient in that. So, but Google knows everything, you know. And so what I did was just a simple Google and try to find out how can you extract figures or numbers or text from an image. And after certain failures, basically, I came up with Tesseract. And so what I did is I tried to go through all my pictures, my images, and try to extract those figures. And as you can see at the very bottom, I was not very successful. I managed, though, just to give you a little bit of a clue what the code means. Do we have a pointer? No? Yeah, but the mouse doesn't come up. Otherwise, I would have done it with a mouse. Do you have one? That would be great. Ah, perfect. Thanks to you. Perfect. So what I do, first of all, with PyTesseract, I read out the information of the image. And with image time, I extract the information from the image when it was taken. So I can extract the date. And this is what I finally come up with. So you can see with the first, I have a sample of just 5 pictures. With the first 3, I didn't get the value. I got it with the last 2, and this is the information, not sorted yet, in terms of like when was the picture taken. A next try was that Tesseract allows for some parameters to be set. I played around with this PSM value, and as you can see, was not very successful either compared to the first try. So the next thing I did was I tried to apply some filters, a contour filter, an emboss filter, a black and white. So I transferred the colored image into black and white, and also some sharpening. And as you can see on the picture, that's basically the original. And these are the results of the different filters that I applied. Doesn't look like much of a difference in terms of like just visually. But I cannot really say a little bit more successful because I dropped one value that I had before, but I found another one. So this is then if I plot it, so again 3 values I couldn't get, and 2 I managed to extract. And the 4th try was really was my final and therefore also my most successful one. Was that there is a really cool website which is called trainyourtesseract.com, and there you can upload a font and train basically the model. And since I was using this Apple Watch, I thought, well, it's probably not going to be one of those standard fonts, but an Apple individual, whatever, corporate identity font. And I found out that the Apple Watch uses the so-called San Francisco font, and I managed to find it somewhere on the web and could download it from some kind of like developer environment. And I managed to upload it to this website and train it. And finally, the command then looks like PyTesseract image, etc., etc. And here you pass some of the parameters. And here, as you can see, there is a parameter called language. And this is basically just what I received after having trained the system here with that link. And again, I just kept this PSM value, where again I played around a little bit and found out that this value was just the best one or just provided me with the best results. What I also did was some image kind of like fiddling around with the image in terms of like cropping it. So I analyzed the image because they all look the same. So the pulse number is always at the same spot, and other information that I needed is always in the same spot. So I try to focus on those areas, crop these, and have PyTesseract use only these in order to avoid any disturbance, etc. So basically, I just cut out from the original image. I went to black and white, and then I cropped out this part, and I cropped out that part, so you can see what I finally was working with. And finally, I managed to get a lot more better results. It's not 100% successful, but at least a lot or way better than in the beginning. So these are some recent values. This is again some kind of like a sample set. You can see this is my quiet pulse. This is then my pulse when I'm awake, etc. And over a longer period of time. Here again, you can see the results, the values, and the dates. And that's basically it. I think. Oh, doesn't work. Hello. I wanted to show you that on the Jupyter notebook. I don't know. Seems to be kind of like dead. I don't know why. Okay. So I'm just gonna very quickly through it. That was the original image. That was the first try. As you can see, it's going fairly quickly. Then my second try was that one. Not very successful either. My third try, as introduced. You can see here, this is what the algorithm comes up with. Oops, sorry about that. So this is the text it extracts PyTesseract, and you just receive it as a kind of like a list, and then you see. So for instance, this is the time, but that's something that's not really correct. Whereas word frequency is fairly good, etc., etc. And finally, my fourth try. As you can see, a lot better results here, and this is what I came up with, again only with the sample data set. So to conclude, I wanted to conclude. Lessons learned. This is where I wanted to go. Lessons learned. So the first solution is not always the best one. I think you can agree on that. I learned to be patient and really plug and play, really play around with that. So just find out what are the parameters the best that suit for this basically kind of like situation. And finding individual solutions, not in terms of like I can apply that to any kind of like problem, but just for that one, increases the quality of the results. And last but not least, and with that I want to conclude, I should get more sleep instead of programming. So thank you for your attention. Just maybe one final comment. You're probably wondering why I presented that at the GeoPython conference. There were basically two reasons. One reason was that I found it's just funny, you know, and if there's a spot left to do a presentation, why not? And on the other hand, you might come up with images where there's coordinate values and you want to extract them to do whatever, then it could be helpful just to extract some information from a picture. And it could be coordinates or anything else that's geo-related. So I thought a long time about a good reason, and I came up with that one, so that kind of like saves me now. So.
Any questions, anybody?
Yeah, very, very interesting. I was wondering, because the Apple Watch also has Bluetooth?
Yeah, yeah, I think so, yeah. Yeah, yeah.
Would it also be an alternative to read data through the Bluetooth API? Has that been hacked?
As I said, I'm not very techy in terms of like knowing how to do that. So you must ask me the simple technical question.
Okay.
But perhaps, I don't know. Maybe, yeah, you can listen to some kind of like information. Probably, yeah, if you're really good at that.
I tried it with Ubuntu watch, but it still has to be hacked. But it would be interesting to read, for instance, GPS data.
Yeah, sure.
But okay.
For me, with this problem, it was not something I wanted to do kind of like real time, you know. Okay. So it's not something that I wanted to, like with meteo data, where you want to in real time get the temperature or any other meteo value and put it into a database. That was not my goal.
Any more questions, anyone? Okay, so let's continue to the second talk.
Okay, then I'm just moving on. Now I think comes the more cooler stuff, but all right, what I'm going to show you in the next presentation is Raspberry Pi, and I don't know why I came up with that. Maybe because I had some. Well, actually, I do not really have some spare time, but for whatever reason. And what I'm trying to introduce you now. Actually, I wanted to do a workshop on that. For those of you who are interested in getting kind of like started with the Raspberry Pi, what can you do with it? Where's the limitations, etc., etc. As for me, I always thought there must be something cool about the Raspberry Pi, but I never dared stepping into it because, as I said, I'm not really a handyman. I have like 2 left hands with 5 thumbs at each hand, and so I struggle a little bit with that. But then I thought, well, why not give it a go? And so I bought one of those. Basically, that's a Raspberry Pi in a case. That's the nearly most current one. Until the day before yesterday, I would have said that's the latest. But I just learned that's a Raspberry Pi 3B Plus. But I just learned that the version 4 has now come out. If you're lucky, you can order it already. And there you have also some kind of like configuration options. This one is just standard. And it's basically just kind of like a motherboard with some devices on it, like connections for an HDMI, like a CPU unit, of course, some pins, some USB connections, Ethernet, etc. And that's it. And you just basically load some operating system, Raspbian on it, etc. So what I want to introduce you with today is how to connect a camera to such a Raspberry Pi and just play around with it. And this is basically my equipment that I used. It's here. So that's, again, in some kind of like case. So this is the size of the Raspberry Pi. That's a 0. That's one of the smallest there is. And it doesn't have the same performance as this one, of course. but it's sufficient for what I wanted to do. And for the other parts, so this is basically the Raspberry. That's the camera module. So here you have the camera. Reminded me kind of like some of the first James Bond movies I watched, you know, where everything was so tiny and he had everything with him, etc. A camera in a watch, etc. That was just out of imagination at that time, whatever. This is a so-called peer. That's a sensor for detecting movements. I'm going to talk more a bit about that later, because I wanted to connect that and then kind of like fire off the camera as soon as this sensor detects a movement. And that's basically just the power, the power provider. So you don't really need kind of like a plug. You can use it with a power bank, standard power bank, and there you go. So you're ready, like, because I'm traveling a lot on the train, I can do it there, even if there's no plugs there. So basically what you need is you need the Raspberry Pi, you need micro SD card, which is this one, of course, and can just be inserted here. That holds the entire operating system and the data. The camera module, the power supply, and the Wi-Fi connection really helps. It's with this Zero, it's a so-called Zero-W module. It's included. I think it also supports Bluetooth. And Noops is the operating system that you use. And when you get started, so here is a more detailed picture of the Raspberry Pi Zero. So basically here this is the connection to the mini HDMI. This is the connection to a mini USB or micro USB rather. And here you have the power supply, etc. And here are then the pins and the option to plug in the camera module can be found there. In order to get started, it's very good to have a monitor, a keyboard, and a mouse for the first steps. Later on, you don't necessarily need that. You can work with it so-called as headless, it's called. So for instance, here I have this is now basically the desktop of my Raspberry Pi Zero, so of this one. So as you can see, I can work on that. That's a VNC viewer. The Raspberry or Raspbian supports this connection. You just you have to make sure that you're on the same network, like for instance a Wi-Fi, etc. And then you can connect like this. So you can use your standard computer infrastructure and work with the Raspberry Pi. Coming back to that, but when setting it up first, I think you need a screen, etc. monitor. So what you basically do first is you just copy, download Noops from the web and put it on the SD card. Simply copy it like you copy any other data on an external device. Then you take out the micro SD card, insert it into the Raspberry. You start it, and then the first time you come up with a screen like that, where you have different options, what you want to install, and I chose the Raspbian. And then it takes a while to install it. You have to do some settings, like language settings, like what kind of, for instance, also some settings like the keyboard, etc., etc. And there you got basically then finally the desktop, which is similar to that one that I showed you here. And then you have like a menu with different options. Like, you know, it's just a standard Linux kind of like thing. You have even some, you can do whatever you want to do, like office stuff, etc., or development. You've got different predefined IDs that are already there, etc. You can connect to the internet. You have a little bit of software for images, etc. You even have games, etc. And finally, last but not least, there is this menu with the settings, which I maybe want to show you quickly. And as you can see, because it goes now through I have a Wi-Fi set up here. Because it goes through that, it's a bit slow. So you define your name of the Raspberry, and there you have on this one, you can activate, for instance, the camera, SSH, etc., VNC that you need to be able to connect like this, like I do, etc. So these are the settings, fairly straightforward. So activating the camera, this is what I did prior to that. And as you can see, this is here, enable. You can also do that basically on the terminal. So if I do, for instance, a sudo raspi config, then I come up with more of that. And then I can, for instance, say I want to have the interfacing options. And there you can see camera or SSH. It's basically just what you had in a bit of a more convenient form prior. Oops, so I'm leaving here again. Finish. And so I have my camera plugged in, and it's sort of like a little bit fixed on this aluminum part. And if everything works right now, I'm supposed to show you a picture of what it looks like when the camera is positioned here. So what I do is, well, after you've first installed Noops, it might be good to just update your system with those commands, sudo apt-get update and sudo apt-get upgrade. And then I just connect the camera. As I said, it's just plug in. And there's a pre-installed software which is called Raspi Still, or the command that I can use. I just copy that. Come here. I have now, for instance, here, this is my directory, HomePy and Pix, which is, as you can see, empty. And now I'm taking my first picture, hopefully. And it is a bit slow, as you can see. I'm going here now to Pix. First pick, as you can see, I'm not cheating. It's really from now. And there you go. There's some, well, this is just in terms or in case it wouldn't have worked. I put that in. I can have, of course, some parameters to play around with, for instance, setting the width and the size of the image. So I'm going to show you that one again. Second pick. Let's have a look at it. Yep, as you can see, it's smaller in size than the original one. You can also see that in terms of like file size wise. There's quite a big difference. Besides the width and the height, you can also set some kind of like a quality value. This is now 50%. And again, firing this up here. Third pick. you go, a bit more size-wise again, as you can see. So this is about just taking a picture. So as you can see, fairly straightforward, fairly easy. And since it's a camera, you can, of course, also do videos. But with the videos, the command is not raspi still, but it's raspi vid. Makes somehow sense. And I'm going to show you that as well. Standard, if you don't get any other parameter, like how long should it record, I think it records a 6-second video sequence. So there you go. If I double click on it, it opens up VLC viewer on the Raspberry Pi. And again, because of the connection, it's a bit yeah, not very smooth, but it works. As you can see, it works, right? And again, here you can, for instance, with a T parameter, you can set how long you want to take the video. For instance, now it's 10 seconds. And give it a little bit of a different angle. So you're supposed to wave now or move or whatever, you know. So it makes the video a bit more interactive and more interesting. So it has finished now. And here you can see also how fast this grows file size wise. So you're still alive. Very good. Yeah. Thank you. Thanks a lot. Okay. So as you've seen, it's really fairly straightforward. So you just plug in, you install the operating system, and nearly everything is there. You can just go ahead. If you want, for instance, to transfer it to your computer, I use FileZilla, have a connection there with my Raspberry and with my local drive, and then can exchange data the way I want it. Or if you want to, for instance, convert the video, there is a package called the GPack that you can use, and then, for instance, convert the raw stream to an MP4, etc. So everything is nearly there. If you don't want to use the command shell to take a picture or to take a video, there is of course some Python bindings, and there what I worked with and recommend is the Pi camera, and there you got some sample code. I'm not going to fire that off now because I want to show you some other stuff, and but again, everything is there. If you want to integrate it into your code, that's the way you do it. Again, fairly straightforward, not much of code. That's a sample that I did at home, etc., etc. But what I wanted to do now is, as I said, I have another sensor here, which is a movement sensor, a peer. And what I want to do now is I have my camera set up that is basically just listening or sleeping. And as soon as I have a movement here, I want the camera to take a picture of what's going on and send it through mail to me. So for instance, I could use that in any other location where I'm currently not present, and I want to know, is there something going on or not? So what I need to do is I first had to set up some Python code for sending a message, so sending a mail. That's what I do here. I'm not going to go into any detail, but as you can see, you can do that fairly easy. Then now with this peer sensor, I also have to do some Python coding. For instance, setting I don't know, you can probably not see it, but with this cables, they're plugged in here to the pins, corresponding pins on the Raspberry. So I have one for power supply, I have one for sending the signals, and I have a third one for the ground. And my pin 7, this is what I define here. This one listens to the movement or to the signal that the sensor is detecting. And then some other code, blah, 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 is listening. This is what you're going to see later on when I show it. And then finally, just deciding if something is happening, like I have detected that there is something going on, take a picture, and here now comes the other part into the game, that I write some Python code that activates the camera and takes a picture, saves it, etc., and then also send the captured picture to my email address. And I'm going to show you that now. I fire that off. I have prepared it here. So I'm making this a little bigger, so maybe you can read it. So what it basically says, it started, now it's waiting for some movement. And as you can see, when I move my hand, something is going on. Just some debugging that I did. The picture has been taken. That's the path and the name of it. And now it's preparing to be sent. And if everything works right, it is sending it to this email address. And it did that. And now it's waiting for another movement. Perhaps you can wave. I don't know whether it's detecting something. Yep. And I go to my mail account. Should have it somewhere. That's not it. Nope. Unfortunately, I seem to have closed it. Yep, there it is. So, as you can see, that's the picture taken just before, and I'm not faking that. You can tell by the time. And here again, some kind of like waving arm. So, as you can see, fairly easy to do. Just plug in the sensor, write a little bit of code, and there you got your surveillance system. And the last thing that I wanted to show you, I'm interrupting that, is there is a package called Motion that kind of like compared. Well, here what I'm using is a special sensor that kind of like has some reaction or interferes with movement, and I think it's temperature based, changes in temperature, and Motion is just basically just picture based. So in other words, it just needs the camera, and when some pixels change, it gets activated. So what I did is I installed Motion, this package Motion. Fairly easy again, sudo apt-get install Motion, and that's what you do. And then a couple of other settings, just minor things. You can find all this on the web. And then I'm just starting now the service sudo Motion. And here, again, it has started, etc. And what I can do now as well is, perhaps you can wave again. It should react to some changes. Yep. And again, I configured it the way that it sends me an image. So it takes a picture, but it also records some video screen, or some video streaming. And I think as soon as there's no further movement detected, it ends the video. But as you can see, you're too nervous. It's constantly sending pictures. So there's some movements going on. Here we go. With this, in order not to have too many pictures, I just set it up that I'm just getting kind of like a hint. Mind you, there's something going on. I'm not sending the picture, but what I can do is I can now, if you for instance move, I have a live connection there, so I could kind of like survey it, and as you can see, there's also the time. And once you're all quiet and still, it will end the video, or I can manually just interrupt. And somewhere there's a video. Yeah, there's. That's not this one. Not sure whether I save it into motion. Now, yes, I guess that's it. Somewhere around here. Probably that one. The timing is not right. You have to add 2 hours. So let's see. Motion. I think that's it. Yeah. I'm nearly finished. Yeah, the problem is I think that it converts motion converts it into an AVI, and somehow I did not manage that VLC is displaying it. It does something, but it's not coming up with a picture. So I would have to have this converted. But that's it. So as you can see, fairly easy stuff. If I can do it, you can do it. And yeah, I mean, it's an investment of around 50 euros. And you have your surveying systems, some surveillance system. I think it's really cool. It's just to play around a little bit, and you can do other stuff. Again, the question, what's the relation to geo? I find it a bit more difficult to justify it at that time, but I'm sure you have some ideas what you can do with it. I have a GPS sensor at home that I could also use. Haven't done anything with that yet. But if you do anything geo-related with cameras, I was wondering, for instance, if you put up 2 Raspberry Pis with the camera, whether perhaps you could do some measurements. What's the accuracy? Might be, of course, it's not as accurate as any other professional system, but maybe it's sufficient for what you need to do. And there you got a very, very, very cheap, low cost, low energy, and cool infrastructure. Thank you. And perhaps next year we can do a workshop on that, if you're interested.
I also think it's really cool. Any questions, anybody? No? Okay. Just a sec.
Just a quick question. How long did the battery power last? Do you think it can last like around 1 day without recharging?
Well, it depends on what, that's really, that's a question to be answered totally independent of the Raspberry Pi. You know, you can, for instance, at home, what I have at home, I can show you that as well. I have at home a Raspberry that, let me check. That constantly saves metadata. So, for instance, these are my current values. So at my apartment, I have 25 degrees right now, which I find way too hot. Outside, it's 30 degrees. And what I did with that, that's really cool. I bought an antenna for around $30, and I'm listening to other sensors of my neighbors. They have their temperature sensors, you know, and I'm just listening to the signals. And I'm reading that out and putting it into my database so I know the outside temperature. And I have an inside sensor this size, which I plugged to my Raspberry Pi that gets the humidity and also the pressure. And so these peaks are, is it increasing, is it decreasing, et cetera, et cetera. This is some statistics, the date, minimum temperature, maximum, et cetera, average. And then I started to visualize that. For instance, the last 12 hours, you can see this is the inside temperature. So what we do is we keep the windows closed and only open it when the temperature outside gets lower than the temperature inside. So I got up around 3 o'clock at night, opened the windows, and as you can see, luckily for us, the temperature dropped. So we had a little bit of better sleep until I got up again, and oops, we had to close the windows. Now the temperature is rising. This is for the last 12 hours. This is for the last 48 hours, and yeah, so why did I come up with that answer? Oh, yeah, this is because of the power question. Excuse me, the power. So I have it just regularly plugged into the block. It's running. I don't know whether that answers your question. Otherwise, you just buy whatever kind of power bank you need. Well, I'm not knowing how hot it is in the apartment, just outside.
We have to finish. Thank you.
Where did he go, Bart go? Okay. Du beginnst einfach. Ich räume da hier noch auf.
Okay. Does it work for everybody? Yes. Seems like. No, it's over here. But it's this one. Yeah, so welcome to my talk, analyzing geospatial data using GeoPandas. Yeah, sorry. Good hint. Thanks. Analyzing geospatial data using GeoPandas. My name is Marvin. I'm a student of geography and computer science in Berlin, and I'm a working student at LiveEO. So we do remote sensing for infrastructure, so for railways or electricity grids, and I do work of geospatial data science for vegetation management. And yeah, let's get started. We are going to talk about data from the real world. So this talk is going to be about whales, it's going to be about geo, and it's going to be about pandas. And yeah, the study region are the Azores, which are a group of islands in the middle of the Atlantic. And there's a huge biodiversity and a huge amount of cetaceans around. And we would like to visualize data from whale watching companies. So, okay, doesn't work. Just, sorry. Okay. Yeah, the Azores located in the mid of the Atlantic. And yeah, why don't we get started with our packages? We import them. We use pandas, NumPy, Fiona, GeoPandas, Matplotlib, Shapely. Yeah. So we import the provided CSV file using pandas. And Moniset is a research platform. So they provide the data collected from the operators conducting whale watching tours on the Atlantic Ocean, and they provide a public data set collecting all the data. And the issue is that it's not possible to make further analysis with this kind of data. And I asked them if they could provide me the CSV file or basically the raw data, and they did, which was very nice. And yeah, let's get a first impression of our data set. And as we can see here, there are some issues. So we have latitude and longitude data, which are the main issue for our data, and there's space, which doesn't make sense. So they use binoculars from land to track the animals, and it doesn't make sense to plot these kind of values. So we should omit them. Also, we have column names which are not possible to read for me because they're in Portuguese. And also we have some non-values, which makes it difficult to plot anything in our further work. So I translated the column names using a dictionary, and afterwards we get something which is workable for me. We delete all columns which are not interesting for our purpose. So I would like to create a plot, and therefore I just need the relevant information. I drop all of the columns which are not kind of necessary. Yeah, for further work, it could be meaningful to say, okay, we also would like to get the time of the day or number of animals and stuff like that. But for our purpose, it should be enough. Yeah, we're also going to delete all observations from land, as it doesn't make sense. And yeah, so we use a conditional expression, and we delete all latitudes with base, and yeah, because it's we need it twice because it's case sensitive, and it should work. Yeah, then we check again if everything makes sense, and we have 4,000 roughly values, but however, we have still some issues here, and we made further investigation to check out what's going on. And we have still any non-values, which we should check. And yeah, we drop them. And now everything should work, but I tried it, it didn't work, and I tried to plot with Matplotlib, and it was kind of strange error, and anything was wrong. And I go the short way now because we don't have that much time. I check again, and we don't have any null values left. But however, it didn't make sense, and therefore I checked for further issues, and I need to do it manually. And later I figured out that there's one longitude value which is not valid, and that makes the plot terrible, and you can't see anything. Yeah. So I dropped this single value, and I checked it again. Now everything should work, and we need to create a geometry to create basically our plot. And we make an operation on our latitude and longitude columns. So we use pandas to numeric to make the data as numeric. We zip the data, we build a list out of it, and we apply the point function from Shapely to create another column coordinates, and we delete the old columns because we don't need them. We display our data frame, and that kind of makes sense. And now we need to convert it to a geodata frame because now we just have a data frame from pandas. And yeah, that's how it looks like after we create a geodata frame. And then we can plot it, and we have the distribution over space from the spatial distribution of the species. And we also would like to see how do they occur in comparison to land. And there's some OpenStreetMap data from the Azores. I just import them as the same procedure before. And yeah, then we join them together and locate them in one map. So we use matplotlib to create a plot. And we load the Azores geodata frame, the all species data frame. We label our axis. We create a grid, and I also limited the x-axis because otherwise we have some islands around which are not interesting for us. And yeah, we also change the background color to make the sea blue. If we look back, it seems like that we have still some sightings on land. Maybe it's also just a visualization issue. We cannot be sure if we just use it like that. And therefore we should check, and we check if the Azores geodata frame, which is the landmass, contains any species, and there are no results. So maybe we should improve the visualization. So there are basically no sightings on land, and our data cleaning worked well. Yes. So now we accessed all species, and you figured out that it maybe doesn't make sense to have such a lot of points in one map. And maybe we're also interested in one species, for example, blue whales, which are passing the island in spring. And therefore we do log, and we make a conditional expression to say we would like to get all species equal to BM, which is the short name for blue whales. And yeah, then we also do the same procedure as before. We convert them to a geodata frame, and basically we are plotting once more. And I think that's a bit more nice than to have all species mixed in one plot. And because there are several species, so there are roughly 20 different species per year which they cite. And the total maximum is 38, which they discovered in kind of history. And so we automate this process. We define a function so that we just need to input our species and make the conditional expression. We create a geodata frame. We create our plot and do some adjustment. Occur there for the entire year. And there are a lot of sightings, which makes me happy. Yeah, some further steps which I should work on. So it was a project work for university, and I think there's an advanced course, and maybe I should focus a bit more on cartography design, because I think there's some things which could be improved for color design and stuff. Also, it makes sense to create hotspot maps to see, okay, where do the species occur and why? Are there any relations to water temperature, to other biologic variables from the sea? And last but not least, to build an interactive and ready version on my own. And yeah, maybe that's something I can do, and then we see each other next year again with an improved version. And yeah, that's it. And thanks for your attention.
Any question, anybody?
Yep.
Okay, just a sec.
Thank you for a good presentation. Do you have this example available online somewhere on GitHub if I want to try out the steps?
Not yet, but we can do it. So I can prevent it, and if we make contact exchange, I can send you an email or stuff that you can access it. Yeah.
Thank you.
Any more questions? Okay, thank you. We're going to have lightning talks in the auditorium at 12.
the University of Paris. They will present IPy leaflet, which I find particularly interesting. And so a Jupyter leaflet bridge enabling interactive maps in Jupyter. You prefer to use the mic, or you already geared up? And you're also going to speak?
Yeah. Okay, thanks. Can you hear me? All right, thanks for the introduction. And thanks, Andrew, for the amazing demos of HoloViews and the Pivot stack. So yes, I'm the CEO of QuantStack, you guessed right. And so I'm also the steering committee member for Jupyter. I also am on the board of the NumFocus Foundation. Just a quick poll in the audience, who knows about NumFocus here? So not everyone. So I'll explain what this is after. And I also organized the PyData meetup in Paris. So if you have amazing stuff to show to the PyData communities in Paris, please talk to me after, and I'll be happy to maybe arrange like a session of the meetup for you. And this is my colleague Martin, who is a scientific software developer at QuantStack. He's also a core contributor to Jupyter, and he contributes to Jupyter, Extensor, IPy leaflet, which is the subject of this presentation, and voila, which is not the end of the sentence, but the name of the library. So he's Renaud Martin on Twitter. So what's QuantStack? So it's a fairly new company. You may not have heard of us. So we are a team of open source developers and contributors to many projects of the open source scientific stack that you already know and love and use, right? So such as Jupyter, NumPy, Extensor, voila, the Jupyter widgets. So we have developers in France, Holland, and Germany, and we do custom development trainings, extensions to Jupyter and JupyterLab in C++. We deal with the raw stack. We also do Jupyter Hub deployments. So if you need any help, come talk to us. So what is NumFocus? So NumFocus is the nonprofit supporting the open source scientific computing ecosystem. So it's the home of Julia Lang, Jupyter, NumPy, SciPy, Pandas, and some other packages, many other packages, including some from the geoscience ecosystems, such as PySAR. And so we organize the PyData conferences with the local communities. So there is a big one in London, there is another one in Paris, Amsterdam, and whatnot. So what is Jupyter? Is there anyone in the audience who doesn't know Jupyter? All right, I can skip that. So Jupyter, well, you all know the notebook, but there's also JupyterLab, the hub, binder, the Jupyter widgets, and voila. So I'll get to that. So I'm actually doing this demo in JupyterLab. So if you haven't seen it, JupyterLab is the new modern frontend to Jupyter. We just released the version 1.0 release candidate 0. And hopefully we'll be able to announce it by next week, the actual 1.0 release for the SciPy conference in Austin. So before we get to IPy leaflet, I just wanted to give you a quick intro to the Jupyter interactive widgets, which you can install from Conda using conda install-c conda for JPy widgets. And so what are widgets? They are special objects which, when they are displayed in the Jupyter notebook, are replaced with an interactive component that can be interacted with from the Python side, either by reading the value, setting the value, and every time we change the state of that widget, it's going to be updated in the front end. So it's a bidirectional communication tool between the front end and the back end, right? In fact, the widgets is more than just like a library or a collection of controls that would be already baked into the core library. Actually, it's a framework upon which you can build. And there are tons of libraries out there that were built upon Jupyter widgets, such as BQplot. IPyVolume was demoed earlier today in the lightning talks. We have IPy leaflet, Py3.js. So tons of these visualization libraries for 3D, 2D, and specialized fields, such as like molecular design toolkit from Autodesk. And Plotly now is also built upon widgets. So I'm going to leave the stage to Martin, who is going to demo one of these multiple libraries called IPy leaflet, a Jupyter leaflet bridge.
Yep, can you hear me? So IPy leaflet. IPy leaflet, like Sylvain said, is a leaflet to Jupyter bridge, which allows you, it's based on IPy widgets, and it allows you to create a map widget. So here I'm creating a map in Python, and because it's...
Sorry? I'm going to hold the mic.
it's a widget, you can interact with it in Python. You can, like, here I'm accessing the zoom value of the map, and I can set it. I can, for example, create a slider widget and link it to, for example, the zoom value of the map. So every time I move the slider, it updates the map. If I dezoom here, it should update the slider. So you have a concept of layers and controls in IPyLeaflet. So for example, I can create a marker layer and add it to the map. It's here. I can drag it around and I can access its position or maybe change its rotation in a for loop in Python. So you see, it's very annoying to go back and forth, scroll up and down, execute code, and see the result on the map. So you can use JupyterLab Sidecar, which allows you to create a view of a widget on the side, like that. So every time you go and update something in Python, you can scroll up and down and you see the result. I will create here a heat map layer. I create a Python function that creates random data. I change the center of the map, and here it goes. If I want, I can create a button that will generate new data on the fly and update the heat map. I can also link a slider to the radius of the points. We also have a GeoJSON layer. So here I'm loading a GeoJSON file, and I will, so it should be visible here. And I will listen to mouse events. So every time the mouse is over a feature of the GeoJSON, I will update the small HTML snippet that I added here.
Close the sidecar.
Yeah, it's better like that. So yeah, and I update, I show the given data on the side. So this is done entirely in Python. There is a bit of HTML code because I added an HTML widget. So every time I will move the mouse, I just update the value of the HTML snippet with the feature property name and the feature property density. Here it's population density in the US. So we have a choropleth layer. Like that. Same as before, I can link the data to a slider widget, for example. We have a velocity layer. So, for example, if you have some ocean stream data or wind stream data, and you want to plot them on IPyLeaflet, you can do it. And here it goes. So that's really cool. That's a widget. So if you want to update the value dynamically, you can do it from Python, and it just works. We have a split map control, which allows you to compare two layers, like that. And because we are in JupyterLab, we have themes. So JupyterLab supports themes by default. So if you change the theme, IPyLeaflet updates itself. So buttons are updated, controls are updated. We have a concept of control, which allows you to, so I was showing a split map control, so controls allows you to have more interactions with the map. So here, actually, I was, in this example, I was adding an HTML control, a widget control, which allows you to put any widget on the map. So here, I will add a slider on the map, which controls the zoom level. I can also add a color picker, for example. And okay, the map itself is a widget. So what if you want to put a map on the map? You can do that. So here I'm creating a mini map that is synchronized with the base map. So every time I move, it updates. You could technically add the same map to the mini map, but don't do it, because you would trigger like an infinite loop of rendering, because the mini map has a mini map itself, and again and again. And
it's mapception.
Yeah, you should not do that. You can add a full screen control, which adds a full screen button, which puts everything in full screen. Okay, and it plays very well with other widgets libraries. So here I have a bqplot. Bqplot is a 2D plotting library in Python based on IPyWidgets as well. So this is a widget, and you can, for example, create a marker that has a pop-up that has the plot, and yeah, you can update the value dynamically. So I don't know, if you have some data related to some city, you can just put it on the city in Python and show the data. Again, it plays well with themes, so you can just switch and it works. So it's very easy to create bigger applications with the widgets libraries. So you have bqplot, you have IPySheet, which is a spreadsheet widget. You have IPyWebRTC, which allows you to do video streaming in the Jupyter Notebook. And yeah, you can combine all of this. Everything is an eventful object, so you can react on changes in Python, creating Python callbacks. Yeah. So people are creating real applications with it. And I'm going to show you another example, which is using Vex. So Vex is a data frame library, a bit like Pandas, which allows you to do to lazily load huge data. So here we have a 24 gigabytes HDF5 file, and when I open it with Vex, it's almost instantaneous. And if I want to plot it, so that's taxi race data. So if I want to plot it with Vex on an IPyLeaflet map, it works.
I just wanted to make sure that everybody appreciates that this is a 25 gigs data set loaded right away. And this is a heat map computed dynamically on this data set, like updating in real time. Every time you pan and zoom on this map, we go over the entire data set of 25 gigs, which is like at the limit of the memory buff of this computer here.
And you can have multiple plots on the same notebook, and it just works. So now, maybe Sylvain will show you Voila, which is another project on which we are working.
So yeah, so the goal of Jupyter is to create like a sort of homogeneous and interoperable set of tools that help the researcher from the exploratory phase of their work all the way to the communication of their work, right? And notebooks, they have proven incredibly useful to provide a narrative next to the code and explain how something works, right? But sometimes you actually want to communicate your results to people who don't want to see any code or who actually don't understand code. And they will even be confused by having to run the notebook, right? There's also a question of security. How do you do this without allowing arbitrary code execution in your environment, right? You want all the dynamicity of the widgets and all these complex applications that you're building without the security constraints. And so that you can just give it to a manager, give it to a salesperson so that they can build an application with it, right? So that's what we've done with Voila. And so Voila is a tool that turns Jupyter notebooks into standalone applications. So it supports Jupyter Interactive widgets. Plotly, it does not permit arbitrary code execution by consumers of the notebook. It's built upon Jupyter protocols and file formats, so it works with other kernels, such as C++ and whatnot. So it's a really language-agnostic dashboarding system, unlike Dash and unlike other tools. So Voila is extensible, so it has a flexible template system to produce rich application layouts. So the execution model of Voila is the following. So first, when you connect to a Voila application, actually the backend is going to open the said notebook and execute all of the cells one by one, entirely in the backend, and serve you an HTML rendered version of that notebook that has a bit of JavaScript that will connect back to the kernel that ran the notebook to render all the widgets and respond to widget callbacks. So it's really secure, and there is no means to execute arbitrary code. Also, as I said earlier, we have a rich application layout template with Voila. So this one, anyone can make a new template for their company using their graphical sort of constraints or like branding. So this example here is an example of Voila template built with Vue.js that allows like some complex layouts in the template. So what's coming in Voila? Jupyter Hub integration, a WYSIWYG editor for layouts, an online Voila gallery at volagallery.org, and winter is coming as well. So I'm just going to give a quick demo of what Voila can do. I should actually have opened a terminal before that. GeoPython. So the easiest way to try Voila is actually to use, pardon? Oh yeah, activate, we close that window. Okay, so the easiest way to try Voila is actually to use the Voila command line utility, which is Voila. And I give the name of the notebook. Now it's running the notebook for you. And here it's serving the demo that we were showing earlier with the population density. So this application here is a completely standalone Tornado application. I'm not going to dive into the complex templates, but you can do pretty much anything the notebook can do already. So it's not the greatest thing about Voila. The greatest thing is actually the name of the library. So as I said earlier, Voila is really language agnostic. So, but before I dive into the language agnostic parts, I just want to give you a quick demo of how Jupyter itself is language agnostic. So as you may know already, you can do more than Python in Jupyter. And there are kernels, meaning the kernel is the part of the infrastructure responsible for executing the code that you type. And there are kernels for other languages. And at Constact, we actually developed a kernel for the C++ programming language. So I know C++ is a compiled language, but there is actually an interpreter that is developed by crazy folks at CERN. And we made a wrapper for it in the form of a Jupyter kernel. So now you can start doing hash include IOStream and like print something, right? Same for errors. We support catching exceptions. Quick help for like standard types or user-defined types. You can do rich display in the Jupyter notebook for C++ objects, including images, sounds, and any MIME type that's supported by the front end. We can do like magics. So if you want to time the execution of a cell, you can do it very easily. Here, like just like in the Python kernel, time it, std random shuffle. We also developed a C++ library called Extensor. Too long didn't read. Extensor is NumPy for C++. ND array, dynamic dimensions, lazy expression, broadcasting, universal functions, all of what NumPy offers with the same API. You can use SimEngine, which is actually the C++ backend to SymPy, but directly in C++ in the Jupyter notebook, and have like rich LaTeX expressions in C++ in the notebook. You can combine these tools together and do joint matrix and symbolic computations with SimEngine and Extensor. And we even support interactive widgets. So here we have a slider, a button, whatever you want. So why not writing backends for other libraries such as IPyLeaflet? So at Constack, pretty much everything starts with an X except for Voila. And so we wrote a Jupyter a C++ backend to IPyLeaflet. And here you go. You have an interactive map in C++. Sorry, the scrolling is not like on my computer. There you go. And updating the mouse position in another widget based on the position of the mouse. And all of this was done without a single line of Python. Right. So, truly language agnostic, no Python in the middle, no Python as a glue, everything, a C++ kernel talking directly to a JavaScript frontend. So let's go back to Voila. And let's run the XLeaflet demo as a Voila application. So bear with me, because right now it's compiling the notebook. Yeah, it's C++. Just works, right? So IPyLeaflet, a bridge between Jupyter and Leaflet.js, Jupyter widgets, a universal framework for doing GUIs in the Jupyter notebook, and Voila. Voila, a means to transform notebooks into web applications, regardless of the kernel. And that is it. We're happy to take questions.
Well, thank you very much. I mean, this was impressive, right? Wow. Calling C++.
How much time? Do we have a lot of time for questions? Or is this...
Yeah, we have 5 minutes for questions almost, yes.
Two questions. Could you compare and contrast VAX with Dask? You know, it seems like similar functionality.
Yeah, so VEX is also provides some sort of lazy data frame system, but it's mostly meant for single node processing, but it's going to be really fast for that use case. And here the data set was 25 gigs. Actually, kudos to the conference organizers. It took us 2 hours to transfer it from my Mac to this computer on the conference Wi-Fi. And it worked. So yeah, it can be really fast using like techniques such as memory mapping and things like this. But it's not a general purpose, parallel processing environment.
Then the second question, IPyLeaflet obviously is Earth-focused. Can we do something where we're looking up instead of down for like the astronomy community?
You can create your own type provider. So yeah, I guess you can.
Although the projection that's used for IPyLeaflet is sort of hard-coded at the moment, so that's the limitation. Some people have made tile maps for Mars, but they had to work around that limitation. Yeah. So not the sky, but another planet. Oh, there is IPyAladdin, which is another Jupyter widgets for astronomical data sets. You may be interested in that. And VEX, the primary use case, was the Gaia dataset. And so you may know that as well, yeah.
Okay, thank you. We still have time for questions. Two at the same time. Yeah.
Please shout, I'll just repeat the question.
Just shout, yeah.
So it depends. First, if you don't have anything in your where you work, like a Jupyter Hub deployment or whatever, one way to go is just to NB convert the Jupyter notebook and send them the HTML file, right? Another way is if you actually have a Jupyter Hub running at your research facility, you can use Voila and actually integrate Voila with Jupyter Hub. And we're going to write another story on that very soon, on how to make dashboards publicly accessible to all users of a hub. Yeah.
And there was another question. Yeah, please use the microphone for the live stream.
So my question is about Voila. I might have missed the point, or maybe I didn't see it. The question, when you compile the notebook and you have the application, how is it actually stored? You generate HTML files and JavaScript files into a directory, and then?
No. Actually, the Voila application is just the notebook itself.
Okay.
And all of the HTML and everything else is generated on the fly for the user. So when you actually hit the Voila application, we spawn a kernel for that notebook, run all the cells, populate the output, serve the HTML. That includes all of the JavaScript to connect to the kernel and render the widgets and power the interaction.
We have time for one more question. Yeah. Could you pass this?
Is a huge project. What is the testing coverage for your code currently?
For which part?
An average.
Oh, like for example, like we have like the whole C++ stack. It's very tested. So thousands of tests for extensor and multiple platforms and whatnot, right? Jupyter widgets are a harder thing to test. So we do test in the core IPy widgets, we do test the schemas, we test that some divs are displayed, like with headless browsers. IPy leaflet is just QA from the notebook. Yeah. Thank you.
Okay, this was the final question. And again, thank you very much, folks. It was very, very impressive.
Thank you.
So debugging again after this session, right? You're all ready? Oh, we'll wait for some image to display.
Oh, doesn't that work?
HDMI 2. You're using HDMI 2?
Maybe it's a resolution.
Are you familiar with this?
I'll try changing resolution, see whether that helps. I'm going to try something else. Give me a sec. Sec. Oops, that was close. Yeah, cool.
Okay.
Does anyone have a laser pointer by any chance?
I have one.
Thank you. Thanks. Okay, hi everybody. Okay, this is going to be a talk that's completely unrelated to GeoPython or any kind of geospatial analysis. This is a cute little tool that I've written for Python, and it could be useful for you in your Python development, whether it's related to geospatial analysis or not. This is a tool called PySnooper, which is a debugging tool. This means it's a tool for these times where you have a bug in your code, and you're trying to figure out why is your code not doing what you think it should be doing. You're trying to figure out where your mistake is. So this is an open source project that I've written a month ago, like a month or 2 months ago. It's gotten insanely popular. It's gotten almost 12,000 stars on GitHub. I was amazed and I was very happy and proud. So in this talk, I'm gonna explain what it is. First, I'm gonna explain how people usually debug their code, and I'm going to explain how PySnooper can help. And I'm gonna show some advanced usage. I'll show how I implemented PySnooper, how it works. And I will also show a different debugger called PUDB, which is also a cute little tool that's worth knowing. And I'm going to try to sell you my consulting and training services. And I'll actually start with that. So my name is Ram. That's my website, pythonworkshops.co. I give Python training in companies. Basically, companies bring me to do courses for their teams, like 3 days or 6 days. So maybe if there are teams in your company that you want to have their Python skills improved or something, please talk to me. I give that service. Okay, so about PySnooper. Let's talk a little bit about debugging code. I'm going to enlarge that. Is that visible? Cool. Okay. So PySnooper is a tool for debugging code, which means that you have your code and you look at it and you think you know what it's doing, but it's doing something bad, and you want to figure that out. This is a random piece of code I found online. This is a function that takes a number and converts it to a binary. So let's say if I were to run it right now. In this case, I told it to take the number 6. I mean, it's actually hard-coded in the code. Take the number 6 and convert to binary, and it gives me 110. It's just a random function I found online just to demonstrate debugging something. So what I like to do is use a debugger. This is Wing ID. Probably nobody here uses it. It's basically hipster PyCharm. It's a different idea that's similar to PyCharm, has the same kind of capabilities, but it's just a different brand. So anyway, I like to use a debugger, which means I can put a breakpoint wherever I want, and I can run the code. And then it's gonna stop at my breakpoint, and I can step through. And at any point, I can also ask him what are the values of variables. Like I could ask him, I have this variable remainder. What is its value? Its value is 1. I've got this variable called number. What is its value? Its value is also 1. I've got bits. The bits is a list with one item. Okay, so that's a debugger, and I really like using debuggers. I use them whenever I can. One of the things that surprised me a lot, seeing how other Python developers work, is that so many of them do not use debuggers. So many of them just don't use them. And the reason is that right now, it seemed really simple to use a debugger because I had just one file. I just ran it. It was so easy. But if I was working in a big company or any kind of complex project, then I would have 100 Python files. They're going to be not on my machine. They're going to be on a different machine. And they're going to be running on a different operating system. They're going to have multiprocessing, multi-threading, and all kinds of things that makes things complicated to connect to a debugger. I think most people don't even know that it's possible to configure a debugger to connect to a different machine or a different OS. Most people don't know how to configure that. So most people don't even want to put in the work to configure the debugger. So what they end up doing is something like this. Right? I'm going to remind ourselves what is the motivation here. The motivation is to understand what the function is doing, follow it step by step to understand where our mistake is in the bug that we would be exploring. So what people do is add these print statements, and then they run the code, and they get this output. And this output is helpful because they can see the stuff that was printed and sort of understand what the function was doing. And of course, they like to expose variables as I did here. And then usually go back and forth and understand that they want to expose more variables and do something like this. Now I'm going to run it. Now it's going to be the same thing and showing more variables, giving me more information about what the function is doing. So I have very mixed feelings about this method because it is, on one hand, it's very ugly. On the other hand, it's very beautiful. The ugly thing about it is that it is so inefficient. As in, I had to go in and manually put these print statements into my code, and I had to decide in advance where I would like to have the print statements, and decide in advance which variables I want to see. And then, of course, after you run it, you kind of discover that you maybe wanted to put the print statements elsewhere. So you kind of do a back and forth where you go back and you add more print statements, like this one. You kind of do a back and forth, carefully crafting your print statements to fit the kind of information that you want to get. And if you have a build process that takes a long time, this can be really annoying. So that's the ugly part. But the beautiful part is that this method always works. And you can praise debuggers as much as you want. Everybody has done this, and everybody will continue doing this until the end of time, because it works everywhere. If your code is able to run, it's able to print. And if you don't have standard output, maybe you can write to a file. So despite how terrible it is just so reliable, so reliable that people are never going to stop using it. Okay, so now I'm getting to what is PySnooper and how is it better. So I figured we have debuggers on one hand, which are very, very powerful but complex to configure, and we have print statements which are so crude, but they always work. So I figured maybe I can do a solution that's somewhere in the middle, that is as reliable as print statements, but a little bit more powerful like a debugger. So this is PySnooper. I'm going to delete the print statements, and I'm going to import PySnooper, which of course you can install by using pip install PySnooper. And I'm going to decorate my function with a Snoop decorator. You've probably seen all these suggestions for arguments. I'm going to talk about them later. So I'm going to decorate my function, and I'm going to run it. Okay, that's a lot of text. Let's reduce the size. Okay, we have a lot of information here. What PySnooper does is basically do something like insert a print statement everywhere. Okay? Now, this sounds crazy. It sounds crazy, and it is a lot of text, but not a whole lot. I mean, this is just a screen and a bit. It isn't as big as it looks. And basically, every line is telling me some kind of information. The first line is telling me that there is a variable I started with called number, and its value is 6. And then every line here of code basically means now the computer has run this line of code. So this is like a sort of automatic log of my function. So play by play, saying exactly what my function did. And the really nice thing is that every time that the variable gets declared or modified, I get a line saying, okay, we have a new variable, bits, it's an empty list. We changed the variable number, it was previously 6, now it was modified, it's 3. So I can basically get a real detailed log of what my function did. So I can understand if I had some misconception of what it did and there was a bug that was hiding because of my misconception, this is a useful way to find it out. By the way, if you have questions, do feel free to interject with questions if you have them. I don't mind. Okay, so I'm going to show some more advanced usage. Okay, there are a bunch of arguments here. Let's just focus on the important ones. The first argument, I can pass in an output. I can pass in a string that's a file path, and then it would write the results to a file instead of printing it in case I don't have access to standard output. I can also put in a callable, and it's going to call the callable with the output. Watch is nice because watch lets me add arbitrary expressions that it's going to watch. For example, let's try this one. Now it's going, besides reporting on all the local variables, it's also sampling len of bits. So it's going to tell me at each point what is the number of items in the list bits. In this case, it's not very useful, but I can put in any arbitrary Python expression. It's basically like the watch feature of a debugger. It's going to watch any expression that I want. If the value changes, it's going to report that to me. Watch explode is the same, except watch explode is the same, except it will also show all the attributes of the things I am watching. And depth lets me if I specify depth that's bigger than 1, like 2 or 3, it's gonna not only show every line of my function, but every line of any function that my function calls. So basically, it says how deep it's gonna go. And if I would put in like 2 or 3 in a fair-sized function, it's gonna create a huge dump of output. But you know, for people who really want to get everything, that could be useful. Then you can grab through it. And I think that the other options are not very interesting, so never mind them. I'm gonna just say how PySnooper works. I'm not gonna go through all the code, but I'll just show how does the magic work? How am I able to insert a print statement between every 2 lines? So let's find the relevant piece of code. There's a whole lot of code, but the real relevant piece is this sys.settrace. So basically, PySnooper is kind of cheating because Python itself provides something called sys.settrace, which lets you give Python a function and then have Python call that function for each and every line of your code. So this is basically every kind of debugger or coverage measuring tool that you know has been implemented using sys.settrace. You basically tell Python, every line of code that you run, please call my function. In this case, it's self.trace. And this function has a whole lot of logic, and it gets the current frame, an event, and arg. I will show you the code. This is the code, but it's so long, it's so complex, so it wouldn't make much sense. But anyway, if you would like to develop some kind of debugging tool like PySnooper, then sys.settrace is the place to start. I'm going to talk a little bit. I guess I got 15 minutes. I'm going to talk a little bit about the makings of a popular open source project. I know that lots of people here might be interested in creating their own open source project. So I'm going to say basically what I did to get PySnooper so popular. Oh, and by the way, regarding PySnooper's popularity, there's even a video of a Chinese guy speaking about PySnooper, which is kind of funny. I have no idea what he's saying, but you know. Okay, so this is the GitHub page for PySnooper. And I've released many open source projects over the years, and most of them haven't really been popular. Only Python Turtle and PySnooper got popular, and I have a whole lot of, if I go into I have 68 repositories, and I kept releasing open source project after open source project, and mostly none of them have gotten popular. So PySnooper made it, and I'm going to sort of try to share what I did to make it popular. Okay, so the first thing is that a very important thing is the README. Something that often gets neglected. And I would say that the importance of the README and of the tagline that you put on your project is about 50% of the content of the project. Because most people, they're gonna see your project on Hacker News or Reddit or whatever, and they're gonna go into the GitHub and they're gonna give you 20 seconds. They're gonna look at it for 20 seconds and try to understand, is this something cool or not? So it's really important in these 20 seconds to really get your message across. So that's why I have that marketing kind of line here. And of course, it's important to explain. This is actually pretty long for an explanation. I would say that most explanations should be like half as long as that because people lose their concentration. People really like this paragraph. What makes PySnooper stand out from all other code intelligence tools? You can use it in your shitty sprawling enterprise code base without having to do any setup. So basically, like, find the pain point, tell the customer, this is your pain point, I know it, and this is what I'm targeting here. And of course, to follow it up with an example that's as simple as possible, as soon as possible. I mean, every GitHub page should have a simple example of your project, of what it does, because honestly, I've seen so many GitHub pages where I just try to understand what the project does, and it's impossible. So the README page is a very important part of getting an open source project successful. Another important thing is posting it on Hacker News and on Reddit. And this is the only kind of dark pattern I'd recommend is if you post something to Hacker News, you gotta have like 3 or 4 of your friends upvote it, you know, in the first few minutes. And that just get it to a sort of, because when you post something to Hacker News, this is the top page of Hacker News. So PySnooper was on the first, like on the top of Hacker News, and then it got to the top of GitHub trending. And then when this happens, things just kind of go viral and get more and more visitors, people tweeting about you, and things kind of happen out of themselves. So just want to get on the top there. And all of the links here are links that have a bunch of points to them. And the links that you post go on the new page. And the new page is where links go to die. Every link here is 1 point. So when you post your open source project, it's going to appear here, and then you should have like a bunch of your friends coming up with it. I would say that 3 or 4 is enough because you don't get like the mass of your points from the friend. You just want it on the top page for just like a couple of minutes. So if other people will see it, it will go viral, and if they don't like it, it just won't happen. So after you get viral on Hacker News, it got viral on Reddit, and then on GitHub, and then things just went out of control. So that's what I would recommend to you if you were doing an open source project. Any questions so far? Anybody? Could you? What's the question? Sorry.
Presenting and running the microphone. He can do it all. Yeah, I was just wondering if you've done any measurements on what the performance impact is of applying PySnooper, because in addition to using horrible print statements for debugging, I also like to use horrible print statements for measuring performance. And I wanted to know if PySnooper could help me with that at all.
Oh, you mean use PySnooper to measure the performance of your program?
Whether it would be even possible, or if PySnooper has too much performance impact for that to be viable.
PySnooper definitely slows your code down.
Yep.
But if you notice, I have these, in the beginning of every line, there is the time of the running of the line, including the microseconds. So you basically got everything right here, right? You can see how long each line took. I guess if I wanted to take a step further, I would display that information in a way that's more appealing. You know what? That's a pull request for you to write.
Yeah. I'll submit it for you.
Cool.
Is there already in place a way to turn on and off the tool dynamically?
Say that again?
Is possible to turn on and off the tool dynamically during the run?
Not during the run, but actually someone added a feature recently that I think the way it works is this. You got this environment variable, PySnooper disabled. If you set it to 1, PySnooper will not work. But you can't do it in the middle of your run. It's kind of environment variable. So, yeah. I mean, I could add that possibility, but people always make suggestions for things to add, and I always have to be careful because it's gonna just turn into a debugger. It's supposed to be a poor man's debugger. If it's gonna be a full-fledged debugger, I have done nothing. I would like to show an unrelated tool, it is also pretty cool, and most people don't know it, so I'm gonna show it anyway. Here is the same code again, same code from before, and I'm gonna show a different tool called PUDB. I know that most people are familiar with PDB. I personally hate it. It's so terrible. I can't see anything I'm doing. Can't see the code. So someone wrote PUDB. Let's show how to install it. Pip install PUDB. Spoiler alert, I've already installed it. PUDB, and to use PUDB, I invoke my code with PUDB instead of Python. And if anyone here in the past has worked with Boland or other similar kind of interfaces, this is pretty nostalgic. This is a debugger GUI inside the shell. That's pretty amazing. I mean, this is SSH. This is inside SSH, and I can. There's a help screen here telling me exactly what to do, and I can type S to step in, and then N for next, and I'm actually seeing all the values of the variables right here. That's a really nice tool. This is a good tool for when you want a debugger, but you're constrained to the shell, and of course, it's not super powerful. It's not a multi-processor, multi-threading, so it wouldn't work everywhere. But it's a really nice little tool to know when you have something you want to debug that's simple and it's on the shell. What else can I speak about? Okay, there is one last thing I wanted to say. I told you that I've used sys.trace to implement PySnooper. That's basically, this line of code is the heart of PySnooper. This is what's telling Python, please use my function after every line of code. And one of the difficulties is, I've got a test suite for PySnooper, and I wanted to measure coverage. I wanted to know how good my coverage is. And I can't use a coverage measuring tool because it is also trying to use sys.trace. And the two tracers can't run together. So it's like in Python, there could be only one tracer, and if you use a coverage tool or a debugging tool, it overrides the tracer. So I couldn't use a debugger on PySnooper, and I couldn't use the coverage measuring tool. So I really wish Python would have let you stack tracers on top of each other. That'd be pretty nice. So like, if I wanted this to be reality, I would write a PEP, a Python enhancement proposal. But it's a lot of time. It's kind of a niche use case. But if anyone would be interested in writing a PEP, I'd be happy to help you. Just have the tracers stacked up one on top of each other, and then debuggers could use coverage tools, and coverage tools could use debuggers. I guess this is everything I have to say. Does anyone have any questions?
Well, give him first a round of applause, I think. Sorry. It's amazing. So, you had a question. I'll bring over the microphone because it adds to the stream.
I have a question. Thanks for this tool. I will use it. I'm used Printed before, I have to confess. Have you had any challenges when you come across the Lambda functions?
Challenges in?
Lambda functions. So which Lambda?
Lambda, I mean, as
The
in
anonymous functions in Python.
Like when someone uses a Lambda function and then try to use PySnooper on it?
Yeah, I try to use a snooper around a Lambda function. Do you have any challenges? Or
I think it would be possible. Let's give it a try. I'm gonna comment all of that. Okay, so this is my Lambda function. Let's see whether this works. Wait. Oh no, it's supposed to be like this.
Yeah.
It does work. It's a little bit unclear because you have multiple logical lines on the same physical line. So it does work, but the output could be a little bit unclear. Yeah.
Yep, that's nice.
So we have, we have more questions.
Is this specific for CPython, or would it work with something like PyPy or JSON?
It works with PyPy, and it is tested with PyPy. Like it's part of the test suite. The tests are always running. I don't think. I know that someone tried to run it on what you call it, the Python. I run Python. Someone tried, and there was a bug, and I fixed it. And I was very proud because I've never used Python before. And it can also be used inside Jupyter. Initially, it didn't work, but I also found a way to make it work. So I haven't tried GeoPython yet, so I don't know. I guess if someone would submit a bug that it doesn't work, I'll deal with it. Yeah. I wanted to dump Python 2, but I know that the kind of people who use print statements are the kind of people who are also stuck on Python 2. Okay, and the most important part of my talk, please buy training from me. Okay, I want to sell more Python training. Okay, any more questions? Okay, thank you very much.
Thank you very much. And this finishes the last session for today, and next we will all gather in the auditorium for the conference closing session. Thank you very much, and thank you very much.